Hey everyone, in this video, we're going to look at example 1 in section 6.1. So here we're asked to find the area bounded between the two curves y equals square root of x and y equals x squared over 8. So in setting up a problem like this, it's helpful to first draw the picture of the two functions to get a sketch and an idea of what's going on. Also, we're not told the bounds other than the bounds of the functions that we want, but we're not told the limits of integration here. So drawing the picture will help us determine where those values are. Okay, so let's go ahead and go for it. So here are my set of axes here. So now square root of x function, that kind of looks like this. It's a concave down function like that. So that's going to be root x. And then x squared over 8. Well, x squared is a parabola, and over 8 just elongates it a bit. So it'll look something like this. So this would be x squared divided by 8. Okay, so we see that these two functions, they do form a closed bounded region like this. So what we need to determine, if we're computing this area in between these two functions, is, well, if we're interpreting this as an integral, we need to know where we start. We'll call that A. And we need to know where we end. Let's call that B. So how are we going to determine those two values? Well, these x values are where these two functions intersect, which means it is where these two functions are equal to each other. So we're going to set them equal and then compute or find x. So we're going to find the x value that makes that equation true. All right, so we've set them equal. So now what do we do from here? Well, now I can square both sides to get that x out of the square root. So that becomes x is equal to x squared squared would be x to the 4th. 8 squared is 64. So now I can multiply both sides by that 64 to eliminate the denominator. So that becomes 64x equals x to the 4th. So now the strategy, I don't want to divide both sides by x, because if x is 0, which it kind of looks like one of the x's might be, then that's an invalid move. I can't divide by 0. So what I'm going to do instead is subtract 64x by both sides. So now I get 0 is equal to x to the 4th minus 64x. From here, I can factor out an x. So I get x times x cubed minus 64. So now I get two different equations that I want to solve for. So this product is equal to 0. So that implies either x is equal to 0 or x cubed minus 64 is equal to 0. One of these must be equal 0. All right, so I can solve. So this one's already solved for, so I can solve for x here. So I get x cubed equals 64. So if I take a cubed root of both sides, I get that x is equal to the cubed root of 64, which is 4. So my two endpoints are going to be x equals 0 and x equals 4. So I can erase my initial a's and b's, and I can put 0 and 4. Okay, so that sets up our bounds of our integration. I'm going to go ahead and erase this to clear ourselves some room. It's important for you to keep all of your work, though, so that when you're coming back to your notes, you can really see each step that you've carried out. Okay, so now let's compute that area then between these two curves. So I'm going to draw a little helper line here. So I'm going to chop up my x-axis. And how would I measure this line or this rectangle that we're going to use to cover the area? Well, the top function here is my root x, and the smaller one is my x squared over 8. So that means to compute the area, I'll use the integral from 0 to 4 of root x, that's going to be my larger function, and then subtract away x squared over 8. And then I need to remember my dx. So now to compute the area, we just need to compute this integral. So let's recall how we would do that. So we have a square root of x, so we can interpret that as x to the 1/2 minus x squared over 8 dx. So now we can compute the integrand of each term here. So if we recall a power of 1/2, so the antiderivative will just be 3 over 2, x to the 3 over 2. Add 1 to the exponent, and then divide by the new exponent, or multiply by the reciprocal of the new exponent. Then we're going to subtract. We're still going to have that 1/8 hanging out, but now that x squared becomes x cubed over 3. So now we're going to evaluate all of this at 0 and 4. All right, so what does that look like? So we can continue our work down here. So that looks like 3/2, 4 to the 3 over 2, minus, and I can go ahead and do this multiplication. 8 times 3 is just going to be 24. So we're going to have 4, let's get back to blue, 4 cubed over 24. Now we're going to subtract when we evaluate at 0, but notice when I plug in 0 for x here, I get 0. When I plug in 0 for x in the second part, I get 0. So we subtract 0 minus 0. All right, so carrying this out further here. I'm going to write, oops, and I see I've made a small mistake here. So I hope maybe you caught it, but this should actually be a dividing by 3 over 2. So that is actually becomes 2 over 3 if we multiply by the reciprocal instead. So I'm going to go ahead and erase that, or feel free to cross it out. Just make sure we have it cleared everywhere. So it's 2/3 here. This should be 2/3. Okay. Awesome. Good catch, those of you who saw that. So now when we compute, we're going to get 2/3, 4 cubed, and then take a square root. So that's going to become 8. So you can do that on your calculator or think through it on your own. Then 4 cubed, that's going to be 64. So we get 64 over 24. So now multiplying these out, we get, and I see I've made another mistake here. It should be 2/3. There we go. So now we have 16 over 3 minus, that becomes 8 over 3 when we reduce. So 16 minus 8 gives us 8 over the denominator of 3. So our answer here is 8 over 3. So that means the area between these two curves is 8 over 3. And as far as units, we don't have a context for this problem, but in this case, we just have, we could call it like square units because we're computing an area, which means we're taking little chunks of x times little chunks of y. So the units would be whatever units are x times the units of y. All right, thanks for watching. And we'll meet each other in the next video where we look at example 2.